Welcome back. By now, you must have already got a sense of how stream programming works in Apache Spark. You learned about the 3-step process of creating stream processing applications. I also talked about the built-in sources, sinks, schema inference, streaming query, triggers, output mode, and checkpoint. In this video, I am going to elaborate a little more on fault tolerance and exactly once processing. So, let's start. A stream processing application in Apache Spark is expected to be running an infinite loop of micro batches. So, once a stream processing application is started, it should be running forever, right? However, running an application forever is an impossible scenario. Even if it is a stream processing application, it will stop for one of the following reasons. Your application might stop due to a fault, such as an exception caused by malformed data, or maybe for some other unknown reason. You cannot create a foolproof application that never fails or stops. Maintenance is another common reason for stopping your application. You might want to upgrade your application, or upgrade the other software, or the overall system where your application is running. The point is straight. Your application must be able to handle the stop and restart gracefully. What do we mean by gracefully? That means to maintain the exactly once feature. Exactly once means two things. Do not miss any input record. Do not create duplicate output records. Spark Streaming API offers you enough support to achieve exactly once. How? Let's try to understand it. Spark Structured Streaming maintains the state of the micro batches in the checkpoint location. The checkpoint mainly contains two things: read positions and state information. And these two things are maintained using checkpointing and write-ahead log techniques that are used by databases to achieve durability and atomicity. The read position information represents the start and end of the data range, which is being processed by the current micro batch. Once the micro batch finishes, Spark also creates a commit to indicate that the data range is successfully processed. The state information is the intermediate data for the micro batch, such as running total of the word count. So the point is straight. Spark Structured Streaming maintains all the necessary information to restart the unfinished micro batch. However, the ability to restart the failed micro batch does not guarantee exactly once. You have the following requirements. The first requirement is to restart your application with the same checkpoint location. And this makes sense also, right? The checkpoint location contains all the necessary information to restart from the point where it was stopped. If the checkpoint directory is deleted or the same query is started with a different checkpoint directory, it is like starting a new query from scratch. The second requirement is to use a data source that allows you to reread the incomplete microbatch data. For example, the file data source and Kafka source allows you to read the old data once again from a given point. However, the socket data source does not allow you to replay to the socket read operation. The third requirement is to make sure your application logic produces the same result when given the same input data. Suppose your application logic uses some date-time dependent logic, or uses some parameters that are going to change the output even if the input data is the same. In that case, a restart outcome is not deterministic. Finally, your output sync should be able to identify the duplicates, ignore them, or update the older copy of the same record. Great. So you can stop your job, restart it, and still achieve exactly once as long as you are fulfilling these 4 requirements. One last thing. Let's assume your streaming job failed with an exception. You started investigating the problem and you realized a bug in your code. You made some changes in your application code and now you want to restart it again from the same point it was stopped. Is it possible? The answer is yes and no. The answer is yes because Spark allows you to make some changes in your code and restart it again using the same checkpoint location as long as your changes do not cause a conflict with the checkpoint information. For example, you found that the error was caused by a malformed input record. So you decided to apply a filter condition to filter out the malformed records. Spark cannot detect such changes, and they will not even cause a conflict with the checkpoint information. So this change is allowed. However, Spark will throw an exception if your changes are detected. For example, if you change the group by column name, the Spark will detect it and throw an exception. Now the next obvious question is this: how Spark detects a change in code? Answer is simple. Spark maintains some information in the checkpoint location. For example, it keeps track of the source and sink. It also keeps track of the running aggregates. So, if you are changing the group by column, Spark will detect it by merely looking at the running aggregate of the previous batch. So any change in the aggregate column is not allowed. However, you should not be getting into the details of what is allowed and what is not allowed. The simple guiding principle is understanding the impact of your code change and making a strategy for the restart. Restarting your application after a code change should go through impact analysis, assessment, and follow a restart strategy. Why? Because even if Spark does not throw an exception, your changes might still corrupt your data. So be careful with the code change in your production application. Great, that's all for this video. See you again. Keep learning and keep growing.